All right, so this lab is called the progressive precipitation of insoluble silver compounds. And I'm gonna give you some tips on the steps, and we're gonna watch the video, but this is the lab that you're most likely going to wanna watch more than once in order to fully understand the progression of things that are going on, because there's a lot going on here. So I'm not gonna walk through all of the calculations with you, but I will show you the actionable steps that will be taken in lab. So the first reaction that'll take place is you're gonna be mixing 5 milliliters of silver nitrate with sodium sulfate into a test tube, and you should see it precipitate. Then you're going to need to pour and save the supernatant. Now the supernatant is the liquid that is above the solid. In this case, that supernatant is a saturated solution of the silver sulfate. And you're gonna just kind of set that aside. We'll be using that in step 3I. The next procedural step in step 2F, you're going to be adding 1 milliliter of 0.5 molar silver nitrate to 1 milliliter of 0.5 molar sodium sulfate into a beaker that contains 98 milliliters of water, and bringing your total volume up to 100 milliliters. In step 3I, you're going to be using the saved supernatant liquid from step 1, and to it, you're going to be adding 5 milliliters of 0.5 molar potassium chromate. Then you're going to shake it up, and you should see a precipitate, and you should see a bright color in the supernatant. So what we're going to do is we're going to decant that. We're going to add water, wash the solid, and then put it into a smaller test tube so that it can be centrifuged. Now, centrifuge is a machine that spins test tubes at really, really high velocities such that we get a density gradient, and so the solids get kind of pulled down towards the bottom of the test tube. This is similar to what they do in blood labs when they need to separate like blood cells and platelets from the plasma. So whenever we use a centrifuge, because it's in a circular motion and there's 6 or 4 or 8 slots depending on which one we use, it's important that we always counterbalance the tubes. That means make sure the forces are balanced and equal. So even though I'm only really spinning one of the test tubes, I'm gonna put in a dummy test tube opposite of it filled with water to the same height so that the weight is distributed equally and the centrifuge doesn't start to rattle, because if the forces are uneven when it's spinning, it's gonna start to get all bumpy and jump around, and we don't want that. So after spinning it, then we're going to shake it, decant it again. The resulting solution that we get should no longer have any color to it, right? And that solution, that colorless supernatant, we want to save in a test tube, but we also want to save the solid that formed at the bottom of this test tube. So we're saving both. In step 5D, we are going to take the supernatant liquid from step 4, and to it, we are going to add 5 milliliters of 0.5 molar sodium sulfate. And we're going to shake and observe. And lastly, in step 5F, we're going to take the solid that we saved from step 4, and we're going to resaturate a solution. So we're going to add 5 milliliters of water to it, shake it up, and we'll have a saturated solution once again. And to this, we're going to see what happens when we add 5 milliliters of 0.5 molar sodium chloride. And that's going to be our final reaction. All right, so in part 1, we are going to mix silver nitrate solution, which is a clear solution. The concentration is 0.5 molar, with 0.5 molar sodium sulfate solution, which is also clear and visibly indistinct. We're gonna take both solutions, mix them into a test tube, see what happens. All right, so clearly we see some solids form. There's precipitate. And we're gonna let this sit for a little bit and let the solid settle to the bottom. And then we are going to decant the liquid off, save the solid, and re-dissolve the solid in 5 milliliters of solution. So we're just gonna let this sit. All right, so we have a precipitate. I let it settle for a bit. We're gonna decant this, and what that means is to pour the liquid off. Now the liquid is called the supernatant. We don't need it in this case. We just wanna make sure that the solid is retained. So there's the solid. Now I'm going to add 5 milliliters of water and shake it up, and so the new solution with the 5 milliliters of water will become saturated again as long as there's some solid left. So that's what we're gonna see. I might need to do this more than once just to make sure that the solution has, the solid has been washed. We have nothing left in here except for the solution of the solid. So we'll let this settle, and I'm gonna rinse it one more time, and then we can be sure that we have a saturated solution. All right, so our solid has settled again. You can see the precipitate at the bottom of the test tube. So we're gonna pour off the supernatant again. Gonna re-dissolve the solid in 5 milliliters of deionized water. And once this settles, I can be sure that I have a saturated solution of our original precipitate. And we're gonna save this solution because we're gonna need this again in step 3. So in part 2, we are going to test and see what happens when we add 1 milliliter of sodium sulfate, 0.5 molar, with 1 milliliter of silver nitrate, 0.5 molar. So I measured out 98 milliliters water. Gonna add 1 milliliter of sodium sulfate. I'm gonna use a volumetric pipette. The line, the marking right there is 1 milliliter. So this is convenient when you just need a small amount. And it goes. Now we're gonna add the silver nitrate, again using a different 1 milliliter graduated pipette. And we add that. Give it a little stir. And there is no cloudiness, no sign of precipitates in the 100 milliliters of solution. All right, so I'm gonna take my 0.5 molar chromate solution, 5 milliliters, and to it, I'm gonna add the saved saturated solution from part 1. And right away, we get a very red, almost tomato juice looking product. So our product, our solid product, is red, and there is a yellow color in the supernatant, and we're just going to let it sit and settle so that we can see the separate layers. So we'll come back to this in just a minute. All right, so some time has passed, and there's a lot of solid present at the bottom of the tube, and we're gonna want to pour off the supernatant. That's what we don't want here. And we're gonna redissolve the solid into another test tube. So, see how there's lots of solid left in there. I'm gonna add some more water. It's okay that I'm adding water now because there's so much solid that I'm gonna end up rinsing this solid anyways. So I'm just gonna shake this around, pour it off, and then transfer it to a small test tube. You can actually see the solids settling. Gonna pour that off. Pour this into a small test tube. The reason why we're going to a small test tube is because we're going to want to centrifuge this. And what that means is we're going to let gravity spin this down to completely separate the solid from the supernatant. So what I'm going to do is I'm going to fill a test tube, another test tube, to relatively equal height with the water, because whenever we put test tubes in a centrifuge, they have to be balanced by weight. So we're gonna walk over here and we'll use slot number 1. And the balance tube will go across from it. So they must be balanced weight-wise. And we'll go ahead and turn it on and let it spin. So we've got nice clear separation between solid and the liquid. So I'm going to rinse this. I'm going to decant this and rinse this a couple more times, because the idea is we want to get as clean of a sample of the solid as possible, so that we can get a saturated solution. So let's just increase the volume a little bit on the left, so I need to add a smidgen more water to the weight balance tube. Put them back in. So I'm gonna keep doing this until the top solution is no longer yellow. All right, so we washed and decanted the solution several times. And now you can see the top solution, the supernatant, is relatively clear. So the majority of the excess chromate is what carries that yellow color, the excess chromate has been washed away. And so we have just the solid now. So I'm gonna shake this up and add this to a larger test tube for use later. And I'm shaking it because the solid won't leave unless it's suspended in the solution. So like if I poured this straight in here, it wouldn't all follow. But now we're able to get it. Okay, so we have our saturated solution of silver chromate. All right, so I'm going to decant our silver chromate saturated solution. And some of the solid followed, but that's okay. That's not going to interfere with the reaction. And so now, this is step 5D, and I'm going to add 0.5 molar sodium sulfate, 5 milliliters. And there's no observed precipitate. Okay, so this is step 5F. I took the solid silver chromate that I saved from step 4, added 5 milliliters to it, and shook it up. And so now we have a saturated solution of silver chromate once again. So we are going to add 5 milliliters of 0.5 molar sodium chloride and see what happens. So now by mixing this, I'm on step 6. And clearly we see a change. We have a new precipitate because it's a different color. So definitely precipitate formed. Notice that we have a yellow supernatant again. So think about what that means with the reappearance of that color in the liquid above. And you should be able to predict what product the solid is at the bottom of the test tube.